Everything's fine. Seems to be fine.
Perfect.
Thank you.
Oh, yeah. Good morning. Hi, everyone. Welcome to RIFT meeting in San Francisco. All of you. Next slide, please. Not well. Seeing your faces around for a couple of years, probably you know everything there. All your contributions to IETF are subject to IETF rules. If you don't remember, top of your head, please read it again. Yes, so code of conduct. Those of you who were in bed this morning, please don't be like that. We won't tolerate bad behavior, no yelling. But again, we've been working together for a long time. We're all nice people, so we take anti-harassment code of conduct very seriously here. So agenda for today, Jordan is going to give us really long talk on progress of base spec, key value, auto VPN, so auto FR, all the stuff that's going around. And yeah, so thank you for doing that work. Then we'll have Sandy talking about Young and have presentation about service extensions. And at the end, we'll have an open discussion. So the DC routing for high performance compute came up as part of routing working group side meeting, and Rift, not surprisingly, seems to be extremely suitable for this kind of environments. So we'll have open discussion on this. And personally, I think we need to rejuvenate the Alia's work on the policy guided prefixes. So I'll be looking, maybe I'll reach out to her and see, I'll probably refresh the draft. So Jordan.
All right. Okay. Jordan Head, Juniper Networks. I'm just going to give a fairly brief update. I'll try not to take 20 whole minutes. First, we'll start with the RIFT base spec. So next slide. So what's new in version 18? Primarily readability improvements as we kind of go through things. So, you know, a few versions ago, we introduced SVGs. A lot of the ASCII diagrams are really difficult to illustrate, so there's lots of value from the SVGs. So basically, we added a pointer to say, you know, stick with the HTML version, stick with the PDF version, so you can get the better reader experience and so forth. Sorted the items in a terminology section, and then improved some phrasing in a couple of areas that were hard to parse. Next slide. Okay, and the applicability draft discussion points. So prior to 116, AD brought up a few points, you know, to kind of clarify with the applicability draft authors and see if there's anything worth including. So considerations for miscabling, you know, the use of 1 versus 255 for time to live and hop limit values for lies and ties, and then implementations that might use IPv4 broadcast or IPv6 all routers multicast. It's in progress. There's been some discussion, but yeah, we'll keep driving it. Okay, next slide. What's next? Just yep. What's next? Just pushing through the AD stuff. So if there's anything I can do to make your life easy, please let me know.
I need to go to my topic. Main thing is get Alvaro stuff.
There are people online. So.
Oh, there are.
Okay.
So it's Jim. Main thing from my perspective is to get Alvaro's stuff squared away, because it it's a little difficult to know what's already been, you know, highlighted and what hasn't. So I don't want to waste, I don't want to do a double whammy on you guys. I mean, there's been lots of review anyway, so focus on getting those squared away, and then, you know, once you let me know, then I'll go through the document again and give you my comments. And I've already given you some, which you've already taken care of a lot of those anyway. So, but it's a long document, so I don't want to go through it, you know, multiple times, giving you the same input that Alvaro had already given you. So if you can focus on that, and then I'll go through it.
Yeah, I'll double
Does that
check.
make sense?
Yeah, I'll double check everything, and I'm pretty sure we buttoned up all of it. But let me make sure, and then I'll reach out.
Jim, your comments have been very, very useful, because a lot of stuff has become kind of obvious, because, you know, when you work for a long time on something, you don't even realize that it's not obvious for people, you know, other people. So it has been very, very useful, and you read it and, you know, you think, yeah. So
Alvaro's comment has been all incorporated, correct?
Yeah, I'll double check if there's a straggler, but there shouldn't be.
So there's nothing pending as far as
Yeah.
Okay, good, 'cause, I mean, I want to get this thing done.
Us too.
and God knows how long ILG is going to read through it. So
Sure, yeah, but, yeah, okay.
please do scan the QR code, so we know you're here.
Even though you may not speak, please do scan the QR code, because that's the blue sheet for us.
I think that's it. Unless there's questions. Okay. On to the next one. Key value. Okay. Same thing. Brief update for key value registry. Next slide. Really minor maintenance here. Just editorial fixes. There's some text that landed in there somehow. Copy paste on my part. You know, reference updates and so forth. Next slide. What's next? Not much. It's essentially cooked, other than maybe basic housekeeping. But mostly just wanted to call out the fact that this is kind of dependent on the main spec. Main spec is what creates the IANA registry for the threat schema, and then the key value components will fall under that. So once base spec gets pushed through, then this will go pretty rapidly after, I think. Okay, next slide. Questions? Thank you. And next one then. Okay, auto EVPN, a little bit more meat here. Next slide. So what's new for version 4? Made some SVGs. There were some minor errors in the ASCII topologies, so I fixed those and we put some matching SVGs against it. So this is one of them, but there's another in there as well. Next slide. Okay. Threw a Yang placeholder in there. It is a placeholder, but, you know, is becoming common. If you can model it, do it. So we'll do that for next time. Editorial pieces, you know, spelling mistakes, reference updates, so forth. Next slide. And yeah, like I said, completed Yang model. We'll go for that. And that's it.
Have the open router folks reached out to anyone here? Any interop testing, anything? Remember, we discussed before last meeting. They were really excited and then they disappeared. Anyone? Anything? Nothing.
Besides the non-interop testing, unofficial ones we did before, I think Juniper and ZT are going to do some offline interop testing as well.
Okay.
So is there a plan to do something like in TC or just in the lab of one of the vendors? Whatever works. Sandy.
Sunny, we just finished our update of protocol. So we are we are going to do the interoperation test in our company at first. So, and then we'd like to do the hackathon in next IETF meeting.
So can we think of hackathon table doing Rift in Prague?
We think we can do it. Yeah, next meeting.
Sounds
yeah.
good.
Tony, on your side, you're okay?
Let me go to the mic because we have that.
Yeah.
Tony P. Juniper. So from our side, everything is ready anytime. I mean, we're like the newest spec and all the addition, blah, blah, all the auto stuff is all implemented there. The basic Rift stuff is all basically ongoing tested against Bruno stuff, which is all open source. And Bruno stuff has all the infrastructure to build, you know, to run tests and build topologies and plug in other daemons like ours. So there's an infra, so you could actually add another daemon because you have to bring the Linux daemon, right? You can plug it in and drive it basically as a mix between different implementation. It annotates, you know, which implementations run on which node, so we can build anything. And he has a comprehensive basically set of PIX pro forma to run against Rift. So the stuff is always up to date. Our newest stuff runs against that. It's not on our website to download, but obtainable. So if ZT brings basically Linux daemon or whatever open router guys, then they can relatively easy, you know, plug it into this infra. But we can make it as a hackathon in Prague, sure. I mean, it's, you know, it is a very quick stuff. All the infra is there.
Would be great to have to ship an implementation that would make it real IETF protocol, right? So.
Well, it's really IETF protocol after it's an RFC, right? Mm.
So Sandy, please keep us updated, and I think it would be great if you could make it in Prague, say, hackathon item.
Okay, when we make some progress, we will send email to you.
Thank you.
Thank you. Just a reminder for Jordan's slides. I guess the font in the slides is not more than 18 size. The size is too small. Yeah.
Okay, for next time.
Unacceptable.
He has good glasses. So, well, I mean, whatever ZT brings, I mean, even the hello, I mean, that's how we started with Bruno, right? We were basically just running IFSM. We don't even have to flat or we don't have to run the ZTP. I mean, it's all optional, right? Even just the IFSM is a start, and then we already, you know, will have a good amount of experience, and then they can push it up the hill. I mean, the more they have implemented, once the hackathon framework is there, you just plug it in and just say which tests to run, because it's all completely broken up by FSM, by feature, and so on. So you choose which tests you run and pass.
All right, one more Douglas Malthon. Sorry, Sandy. Bit of an update on auto flood reflection. Next slide. So what's new here? So we added the common flood reflection thrift model. It's the same as common EVPN and auto EVPN. It just carries the core components, right? You know, IPv6 loopback, v4 loopback if we're using it, ISO address components, cluster ID, all that. Next slide. Tweaked IPv4 loopback derivation a little bit. So originally we were using the same function for everything, but you know, we wanted to make sure that the flood reflectors themselves always work. So broke it up into two different functions. This is for the IPv4 flood reflector loopback address. Basically, the more interesting ones on the next slide from the client perspective. Yeah. So basically, whoop,
too far.
No, it's okay. Basically, we carve out bits from the mask from what we use for the flood reflectors, so that the clients don't collide, right? And then, you know, we'll have some indication of that. It's okay if a client node doesn't work, but the flood reflectors must work. So that's the overall goal for it. Next slide. Some miscellaneous type changes, not really type changes, but several of the actual names have, you know, unsigned, prepended to flood reflection cluster ID type is now unsigned flood reflection cluster ID type. It's mostly cosmetic, but it makes for a little bit of less code with casting. Same thing with auto EVPN, gang placeholder. We'll get that done, and then editorial pieces, right? So flood reflection just hit RFC status, so reference updates and so forth. Next slide. I think that's it. Oh no. Complete Yang model. Yeah, and as far as working group adoption goes, I know this has been kind of an ongoing discussion, but there's a rechartering discussion. I think in Yokohama we talked about once the base spec goes, we'll have that discussion more formally. Yeah. So it's kind of still in that state, but okay. Next slide. Questions, comments.
Good work.
Okay. Thanks. All right.
Next one is the Yang update.
Tony P again, just a side remark. So the changes going in right now into the flood reflection and auto EVPN stuff is basically based on real testing on stuff that we have, and basically, operational field experience and people playing with it, jumping up and down, doing strange stuff, which is always a good thing.
Good afternoon, everyone. I'm Sandy Zhang from ZTE. This presentation is for the update of Rift Yang. I presented this draft on behalf of our co-author, Yuehua, Shaowen, Xufeng, and Bruno. Next. So the Rift Yang model is defined according to Rift protocol. The model includes protocol configuration, state information, and some notifications. And we add some features to enhance the protocol. So the model includes the mode supports multiple Rift instance and node configuration and state, and interface configuration and state. And also we support neighbor and database state, and also we support notifications. Yang Doctor has reviewed the previous version 03 and say it's almost ready. And recently we made no more significant modification. And the changes is about some small modification, such as we align with the modification of Rift protocol. We modify the receiving IPv4 address from 120 to 121, and we add the MTO size, and we add some leaves default values, eccentric. And also we make some improvement according to the suggestion from Tom. And the unsolved suggestion will be addressed in next version, such as add some abbreviations in the draft. So this draft has completed the working group last call, and now it's in IST status. We welcome more review of this draft. Thank you.
So it's Jim. Thanks for the document. I just wanted to state this is in my queue, but unless somebody tells me otherwise, I don't plan on doing anything with it until such time as the spec's gone through.
Yeah.
Didn't seem to be much point, because if there are changes that are needed for the spec, then presumably the Yang model will need to be updated as well. So, just wanted to make that clear, so you don't come knocking on my door saying, "What are you doing with the Yang model?"
Thank you.
So you mentioned there will be another revision. Is that
Yes,
a big change or?
Little change.
Little change.
Because they want Tom wants us to add some abbreviations from Rift protocol into the draft, so
Okay.
we will add it.
Small change. Okay.
Yeah, small change.
Thank you.
Okay.
Yes, we can hear. Please go ahead.
Hello. Hello, everyone. Hi, this is Changwan Lin from New H3C Technology. I will present this draft on behalf of the co-authors. This draft is about Rift extension for SRv6. Next page, please. So background, why we need SRv6 in data center. Using complex SRv6 in data center brings several advantages, such as simple end-to-end protocol, enhanced TE capability, better SFC function, and simple network programming. Next page, please. In data center network, we Rift using SRv6 and SRv6 N.X make it possible to bypass congested nodes or links. When network congestion is detected, the controller can optimize network forwarding performance by distributing segment loading paths to avoid congested paths. For example, in the figure on the right, if either the SPI node 11 experiences congestion or the link between leaf 21 and the SPI 22 becomes congested, the controller specifies a forwarding path from leaf 21 to SPI 21 and to TLF2 to SPI 12 to leaf 11 to optimize the network performance. Yeah, next page. Let's take a look at how the ISP protocol to extend it to support SRv6. At a high level, the extension to ISP consists of the following. Firstly, an SRv6 capability TLV is advertised to indicate the support of SRv6 features and SRH operations, such as the local block length. Local block lengths are also necessary for SRv6 complexity. Secondly, several sub-TLVs are used to advertise, such as SRv6 MSD length. Certainly, the SRv6 locator information is advertised with SRv6 end seeds, including the endpoint behaviors. Fourth, the SRv6 neighbor seeds are advertised. Also, lastly, BP protocol is used to advertise LS information, including the SRv6 LS information. On the other hand, Rift only required the SRv6 locator information and the SRv6 neighbor seed information to be advertised based on its own layered protocol feature. Also, the block length and the node length is necessary for SRv's complexity. Next page, please. The Rift extension for SRv6 is primarily focused on three aspects. Firstly, the SRv6 locate QATIE for ZTP is expanded to configure SRv6 locator information. SRv6 end seed locked to each node and SRv6 end.x information locked to each link's neighbor. Secondly, the SRv6 locator prefix TIE is extended to support the generation of the locator prefix. It considers of northbound and southbound components. For northbound, the locator and the SRv6 and information is advertised. Well, for southbound, only the locator subnet route is advertised. Certainly, the SRv6 neighbor seed are added to the neighbor's TIE information. For northbound, the end.x information specified to the link is advertised to the controller, while for southbound, only the information about the directly connected neighbors is advertised. The next slide. The procedure of traffic forwarding in Rift SRv6 networks has following steps. Firstly, traffic steering based by SRv6 policy in the head end, and then the forwarding path may be an SRv6 end or with specific node or SRv6 end .x will specify the link forwarding. Next page. Let's take a look about the SRv6 locate KVTIE for ZTP. The SRv, firstly, the controller is connected to the TLF and dispute the configuration of all routers, including the SRv6 locator and seed of each router to TLF. Then the TLF sends this information to all routers in the network through the newly defined SRv6 locator KVTIE. Secondly, after the device establishes neighbors, the neighbor's information is transmitted to TLF through northbound node TIE and passed to the controller. Thirdly, after receive the neighbor information of the router, the controller configure the end.x seed for each neighbors of the routers and pass the corresponding end.s seed information to the router through locate KVTIE. Or finally, all routers can obtain the all locator and seed and end.x seed configurations through SRv6 locator KVTIE, achieving zero configuration. Next page. The definition of SRv6 locator KVTIE. This TIE contains SRv6 locator and SRv6 and .x information for each node in the network. The SRv6 locator entry include the device of SRv6 locator prefix and SRv6 and seed information. Next page. SRv6 and .x entries include the definition of SRv6 and .x and its associated attribute for specific links in the network. Next page. Now let's take a look at the role of SRv6 locator prefix TIE. In normal situation, the SRv6 locator prefix TIE are only sent northbound. However, if a node detects its default IP prefix include one or more locator prefix that can be reached through and that node but not through other nodes at the same level, it required explicitly advertise those SRv6 locators in source TIE. Next page, please. This page we define the SRv6 locator prefix TIE is a new type of TIE. It is used to advertise locator address and status information. The specific define can be found in the link below. The next page. End.x set is advertised by the neighbor's TIE element in the node TIE. Next page. These following two slides we offer the two brief overview of examples. First example is SRv6 with JTP. When the JTP mode is enabled, Rift for SRv6 support the following workflow. Firstly, control distributed locator configuration of SPI 11 to 12.1, which include the locator prefix and end set. Secondly, TLF generate the SRv6 locator KVTIE and propagate to SPI 11, which will get the SRv6 locator configured. Thirdly, the SPI 11 and the leaf 11 establish neighbors and transmit the neighbor information to TLF1 through the northbound node TIE. Finally, the neighbor information is passed to controller and force the controller assign end.x set for these neighbors and pass it to the SPI 11 through the update SRv6 locator KVTIE. Next page, please. Another example is about without JTP. When the JTP mode is not enabled, Rift for SRv6 worked as follows. Firstly, the SPI 11 menu configure SRv6 related settings, including SRv6 locator prefix and end set. This piece of information are then propagated to the TLF via the north SRv6 locator prefix TIE. Secondly, in the source SRv6 locator TIE, only the locator prefix information is advertised. Thirdly, although the SPI 11 and the leaf 11 established neighbors, they unlock the corresponding end.x set based on SRv6 configuration. The end.x information is then advertised by inserted into the neighbor information in the node TIE. Yeah, next page, please. Yeah, that's all. Any questions, comments are welcome. Thank you.
Tony, go ahead.
Jim, if you want to go first, because I have something very extensive on the whole.
So this is Jim with no hats on. There's a lot of detail there, and I haven't read the draft, and the devil's in the details, but the very obvious thing that jumped out to me was in the default Rift case, if I'm a leaf or I'm down near the bottom, then I essentially have a default. So how do you take care of, I mean, does the draft take care of the case where, is this not going to cause me to basically have an explosion of more specific routing information going down the tree, if you want to put it that way, where I end up with essentially breaking the good property of Rift, where it just sends the default down. Now I need a whole bunch of other stuff. Otherwise, I'm going to follow the default, which may not be the path that I want. Okay, good.
Oh yeah. No, I I have a massive amount of stuff. So Jordan, keep up with the stuff. I assume there's a recording because it will be dense. Okay. So in general, so I read the draft. Yeah, I mean, good attempt to go about the stuff in the first, naive iteration. As first, I think the work has very high value because you doing the right thing for probably the wrong reasons, which is still good, right? Because who knows, the SRv6, no, yeah, maybe useful, maybe not, it's fine. But you're pointing at an interesting problem. We have the same problem, for example, if we want to ZTP the whole V4 address assignment, because it's impossible to derive automatically, right? There's simply not enough V4 address space. So what you end up with is basically a DHCP server at the top. And the natural reaction is to use the key value store to push the stuff down, all right? So I'll talk about that. So let's talk about more generic, and then I point you at encodings and where more specifically you will encounter problems of how we address it. So yes, you try to abuse the southbound, seems to me, as a broadcast mechanism on the fabric. Which you can, but the state explosion and the broadcast will limit you very strongly in terms of scalability of the whole thing. And I'll talk about how to avoid it and why it would be generically a very good solution. So this draft should evolve into something much more generic, and this will be just a specific case. Simple observation. Going sideways a little bit, you don't need special positive or negative disaggregation. Those are just V6 prefixes. RIFT will take care of that. You may add to a prefix that it's actually a SID, but that's just a tag, right? We have these attributes. It's like a loopback, it's whatever. You can just add it's a SID. But otherwise, the whole V6 machinery that we already have would just magically work. It will do positive disaggregation, negative disaggregation. There's absolutely no need for that. Now, if we go and start to talk about why this will not work and how to bend it to actually not only solve good scalability, ZTP that you seek here, but use the same mechanism later to do things like V4, DHCP, or whatever comes where you really want the leaves to be configured from a controller and from the top of the fabric without state explosion and broadcasting. So let's go and look at the locator key value tie. That is on 8. Okay. Can you flip to PowerPoint 8, please? Because that will help everyone to follow that. Perfect. So now, if you try to stick all the systems into the single key value, you will blow out the MTU, right? This key value will become 60 kilobytes, and you try to flood it through the whole fabric. And I can guarantee you it will work with Juniper Silicon, but that's about it. If you start to fragment that much, basically anything that you touch in terms of cheap silicon will just belly up. So sorry, I should be less informal. It will die, right? So you have to break those things in roughly MTU size pieces. The RIFT on the very consciously does not prevent fragmentation, right? For a lot of reasons. So you can fragment a little bit, but you try something like this, you will die. So you have to break it up in, reasonable pieces. So now let's think how you break it up in reasonable pieces. The simple reasonable piece would be you just use system ID. But if you look at the tie-breaking rules of the key value store, you have the well-known, and then you have 3 bytes. And you cannot hash down the system ID into 3 bytes. You'll have collisions. So basically, the tie-breaking southbound will start to throw information away. And that's where I think this draft, and we can push the key value store farther, will become extremely interesting. Namely, we can come off the well-known and define the new key value where we actually change the tie-breaking rules and we put the system ID into the key value primary key. So we could do well-known, this 3 bytes, or even omit the 3 bytes and put the system ID. And it becomes like a targeted southbound key value. Because don't forget, when the stuff goes southbound, everybody knows who is southbound of the node. So you know whether you need to keep forwarding it towards this guy or whether you can drop it. And that way you avoid broadcasting on the fabric and you can actually target every leaf. Now, this preconditions that you do not assume that every leaf on the fabric has to know about all the other leaves, because then you literally end up in broadcast flooding. And then it's, if you have such a problem, then I would strongly advise that you initiate from the top or from the controller over the top tunnel, and you pump this enormous amount of information to every leaf specifically. Because abusing routing protocol for that will end up in tears. There is no upside except melting the thing out. All right, so I hope that parsed, at least for like the senior folks around here, and from the nodes you should be able to reconstruct it. All the rest is fine. So from my side, I would encourage this work strongly to evolve into something more generic, where we either define a specific key value southbound, okay, because northbound doesn't make any sense, where we tie break on the system ID, so you can literally target people with their specific configuration. And whether we just pick up, instead of a well-known, another code point and then say this thing is being tie broken differently, or whether we define a completely new tie, I don't care, all same to me. Those are mechanics and encodings. And then we use this generic mechanism to support this work, which, I mean, if you want to run this as RV6 that way, fine, right? Unless I'm mistaken and you really want all the information everywhere, then I would say go over the top, right? Just push the common locator, but don't try to give everyone the index of everyone, because that will simply melt out the whole thing. Right, and you don't need a disaggregation. That is automatically taken care of, and maybe add that it's a sit on the IPv6 prefix. If that helps things, probably a good idea. Did I miss anything? I'm thinking. No, I think that's it. So I think we should go in this direction, but in a more generic way, and this will just one application of such a store. And then the next good draft will be something like define automatic v4 address assignment from the TOFs. But that will lead to interesting discussion, because if you do it from the TOFs, then you have to synchronize the TOFs, right? Because basically what you're building is a primary and a backup DHCP server, which we can do. Or we can actually literally use DHCP and say stick the DHCP into key value stores. You don't need proxy DHCP. But as we have another complicated discussion, right? It is all doable. If the controller does it, controller is spot. So here the problem is simple. But you can imagine technologies like AutoFabric, where you choose 2 DHCP servers and they assign this thing, but then they have to synchronize this primary as backup. Okay, hope most of the parts, it's recorded. I'm sure Jordan had stunningly precise, notes of this thing, and I'm here to bounce that stuff off in case any of the stuff didn't parse clear. Thanks.
Any response to that?
1 minute.
Hello?
Oh, yep.
Charles,
Go ahead.
here's me. This is Wu Changcheng. I'm also calls. So thanks to Jim and Connie. I think it's very good input for us. This is the first revision of the draft. I think we just want to put the basic idea and the requirements to this draft. So for the Rift rules, we know that. But here we add something such as something for ZTP because we believe if you want to use Rift in the real network, you have to support the basic requirements from the cloud operators. ZTP is the basic one. So maybe the Rift rule is important, but the requirement for the application scenario is also. So we hope to see if we can have some solution to enhance the Rift for the future. This is the first point. And the second one, I think there are some detailed suggestion from Tony. I think it's valuable. Tony just mentioned about something like DHCP. I think the similar work have been done now in Spring Working Group. We have a draft that extend the DHCP to allocate the locator of ISAV6. So I think maybe something of that draft can be reused to enhance the solution here, maybe. And yes, of course, we need more work on this draft to make it make it feasible in the real network. So thank you.
Yeah, okay. Yeah, I think at like very high level, we're in sync. Again, observe that architecturally, you cannot flood information of every leaf to every leaf because then no matter what protocol you take won't scale, right? As long as this is not a requirement, we should push it to this more generic mechanism, and then we start to put this in and DHCP and whatever it is where the leaves need to be, or even every node on the fabric needs to be ZTP'd somehow from the top or from a controller. And I think it's an extremely valuable addition, right? Okay.
So please keep it short. And you had a comment, Dim?
Huh?
You had a comment, or?
Yeah, I should be in the queue.
Yeah, go ahead then.
Yeah. So 2 comments. One is about that congestion control example. I think that especially in the data center, congestion events are usually transient and they're quite fast. And if you try to introduce controller resolve, basically reaction time just would be too long to do something useful. And if there is a persistent congestion, it's actually a problem of traffic engineering. So example is valid, but I think it falls squarely into the problem of traffic engineering. And for that, it's a valid example. We should be just precise at what we can do so people don't get false hopes.
Yeah, that kind of too.
Yeah.
In line with what Dima said, you know, there was proposal to use third-party BGP next hop. It has never been deployed, never worked. So.
Yeah, and comment to the comment about things which we can to distribute, want to distribute from TOFs, and where TOFs should be synchronized. I think we should also think a little bit about. We are kind of approaching a territory where full-blown distributed consensus protocol would be a proper solution. So probably we should provide guidelines what should be done with Rift and where we should be looking at proper distributed consensus.
We probably should move the discussion offline unless we want to eat into the time of the next discussion.
Yeah, right. So I gave it thoughts, look at the auto fabric, look at these things. We can actually talk about how we synchronize it even without horizontal links. I already gave it thoughts, so there could be possible draft to spin out for a primary and secondary, right? I mean, the election mechanism we already have, that's simple. And then the synchronization basically needs a tunnel between the two nodes, and that's about it, okay?
So if there's a feeling that kind of, especially if the proponents have digested what you said, potentially we could have an interim and not wait till Prague to discuss in more details, if there's an interest. So let us know.
Okay, so the next topic is a discussion on the Dragonfly topologies and the rifts. I put up the slides, but it's not for presentation. Just in case people need to refer to some pictures. So I put up the slides. Yeah. Plus. Okay. Plus or plus?
Yeah, it's somewhere. Yeah, right.
Yeah, one of those probably.
You see, I'm already plus.
So this would be good enough, right?
So I guess people familiar with this topic will be able to basically discuss this and then discuss relevance with Rift. I guess Dimitri, Tony, and Jeff, and whoever else online, just speak up. Yeah.
Tony, do you want to start?
So sure. So I looked at the Prezos, right, and I want to stay polite about these BGP solutions and so on. It's just endless amount of complexity, right? There are kind of two orthogonal topics. One is, can Rift support the Dragonfly topology? If it's regular, are we looking, at the left picture or even of the right picture? If you look, it's really nothing but the multi-plane claw that needs just, one link to synchronize the planes as described in the draft. The Rift will work out the box. But the AIDC will lead to, sticking new things into Rift, which is fine, right? Because we want all this metric, we want, class of service and so on and so on. And that's also fine. And it's actually southbound an interesting discussion because we run into the fishnet topology. You're familiar with the stuff, right? The quality of service with the fishnet is basically very difficult to do something with it. And the northbound, the question is, how much topology do we want to expose, right? To do perfect computation. And no matter what, this thing will react in best implementation tens of milliseconds. So you can only do very coarse load balancing, but you already get for free all the path saturation. So no VPN, none of that is necessary. And from there on, it will be a congestion, notification discussion, which is a microsecond of discussion which is out of scope of routing, practically speaking, no matter what you dream up. So happy to support this Dragonfly. Easy to describe how you would do it with Rift, as long as it's a full, right? No, it will also do partial, but then you start to get disaggregation. And the discussion of which metrics we should stick in and what computations we should support, that's kind of almost Rift version 2, methinks. I mean, it will be backwards compatible if you want, but I think it leads to Rift version 2 with support for all these additional metrics and class of service and so on.
Which potentially will be part of rechartering discussion.
Right, because then we start to talk about, of course, load, right? We also start to not only the class of service, but also distribute load, right? To get some coarse, non-equal distribution, because we will be not just reacting to available bandwidth like Rift does today, but we'll probably start to stick more stuff. Don't ask me, we always have to to think about this couple of 10 milliseconds, right? And this will be the fastest protocol you can build anyway. So like, you know, anybody assuming they can do microsecond or millisecond, that they're just smoking something which is not in realm of realities, right? In my experience of good many years.
Okay, so this a discussion of what was already presented. First, I agree that Rift actually should be very easy to make work in this topology because it even has horizontal links between spines. It's even better than multi-stage claw for Rift synchronization, actually, especially dense Dragonfly. Yeah, and even in sparse Dragonfly with some tricks, it's probably easy to make it work. I mean, I don't see serious problem. It's kind of make it. Okay.
Okay. Oh, so it's like karaoke.
Okay, we can have your discussion. Yeah. So, anyways, there are several possible solutions, and I don't see a problem here. Where one of the problems lies is that good thing about Rift is that it allows to summarize information towards leaves. But in Dragonfly, especially in sparse Dragonfly, we can't really do that because not all the spines are valid for all the destinations.
No, yeah, but then Rift will do that automatically for you. You will either get positive or negative. I mean, the stuff is built in, right? For
I mean, Rift allows you to have really good summarization, and because of topology here, you just cannot do that, and Rift don't do magic here. It will do what it can.
No, look at, so the dense is simpler, but look at the sparse.
Yes.
If you introduce a horizontal link between each of those two purple things, you will find it is homomorphic to figure 13. As topology, literally, it's homomorphic.
But yes, but capacity.
Well, the horizontal links are only used for flooding. Don't forget, Rift will never forward unless you have failures.
I'm talking about topology for forwarding because you shouldn't use all the spines for all the destinations in sparse Dragonfly.
I mean, as long as you have reachability, I mean, Rift tries to saturate all the stuff, and you calculate bandwidth. So you have less bandwidth, you will put less traffic. You already have that.
And here's another thing: is once again in dense Dragonfly, something approximated equivalent load balancing is probably enough. Not optimal, but close enough. So we can kind of load balance or maybe do weighted load balancing. In sparse Dragonflies, we have a minimal +1, minimal +3 paths. They are really not equivalent. And ideally, we want to fill shortest first, shortest +1 next, and longest path after that.
What's the reasoning behind it? Okay.
Difference in latency.
Difference in latency, and also you are using more network capacity. The same traffic goes through more links, and there could be local traffic there. We don't want to do that.
Yeah, okay, but then you talk about blocking probabilities, and for that you need to understand the load. The delay I'm with you, but that you can fix with computation. Right?
Just to summarize, now static allocation scheme can do optimal traffic placement here, so we need some kind of adaptivity.
Well, look, but that's my observation. We can only approximate on like tens or hundreds millisecond scale, and from there on you need congestion control.
After that, you do it on the endpoint. Yes, you can. You can do it fast enough here, and Rift is probably the fastest thing among routing protocols.
Yeah. Okay. So.
Yeah. This is Wuchang. Could you hear me? Sorry for interrupt.
Just one more remark. Is that
he's remote. Let him talk.
Okay. Yeah.
Sorry for jumping in. I'm online, and so currently we also have a draft, and I think it provides some gap analysis and the problem statement on the thing you just talked. So if we currently the Dragonfly topology, I think mostly are using in the HPC application scenario, if you want to use that for such as AI computing, I don't think it's powerful enough because you know the HPC application scenario is totally different from the AI application scenario. HPC just focus on the single task, but the AI application scenario for the network, you have to meet the multiple activities in parallel. So the congestion and load balance and the latency between different links, the requirements are totally different. So I think currently we are talking about the Dragonfly. We should clarify which application scenario we want to use Dragonfly in. So from my perspective, HPC application scenario it's already mature, right? The most of HPC data center they are using the Dragonfly. So for that application scenario, maybe we can consider if we can enhance the protocol, such as if we can use the Rift idea to enhance the solution. And if we want to use that for AI computing, I don't think it's feasible this moment. So yeah,
I'll take it as a brief chair. I don't think you're right to begin with. I mean, just because you publish drafts that focus on HPC, it doesn't really mean anything, right? So you want to solve HPC problems, please do so. I don't think HPC as segment in industry is interesting enough actually to solve. So I think we would all agree that what we are looking at here is more towards ML clusters than HPC, right? Hence, we are talking about networks with fat flows, low entropy, and this is where it can really help. Another interesting point specific to Dragonfly, so, you know, AI is very power hungry, right? We are going to racks towards 60, 80 kilowatts per rack. And if you look at availability of electricity, not only in US, kind of around the world, getting above 60, 70 megawatt is extremely complicated. And it seems that this become kind of natural boundary of data center. So think about 60 to 80 megawatt. So in order to connect this, you would need to build longer links with potentially span of few hundred kilometers. And this is where Dragonfly really naturally allows you to build clusters within data centers, but then also longer one links between data centers. And so it's extremely applicable to AI, and Reef could be a great solution here.
Well, I mean, since whatever the DC buff.
Sorry, I just want to clarify. So I did not deny the advantage of the Dragonfly, but at this moment, if you want directly to use Dragonfly Plus for AI, I don't think it's enough. As you know, it's maybe save power consumption, but it cannot provide the enough performance, right? If you cannot meet the AI performance, it's not feasible. That's a problem. So maybe we need some more work on that, improve that to meet AI requirement. Yeah.
Let me interrupt for 1 second. The meeting time is officially over, but I think we can continue this discussion online like this. We can continue until we get kicked out. And everyone else, if you need to go somewhere, please feel free to do so.
And to close this discussion, Tony, before you, during the breakout, we didn't get to see presentation from Tencent, so because of technical difficulties. Their slides are available. So if you look into last slide specifically about the Takao TCCL, it's a addition to communication library that makes it topology aware. We're not going to talk about kind of virtualization, distribution traffic in machine learning clusters. However, you can see in their examples that making communication library topology aware and distribute ranks could lead to performance improvement 30–40%, which is huge in terms of numbers. So that's another place where we can potentially play because of, ability to distribute topology in a very easy way.
Yeah, so I kind of close with having heard that, right? My opinion kind of stands since DC1 or whatever, 100, since the IETF, the BOF. We have 1 woman and 8 women won't help to bring out the child faster. Physics apply, right? So, and economics apply. So if you build locally a large substrate, you will end up on CLAW. Just economics will push you there, right? If we start to connecting over large distances, yeah, this stuff makes sense, right? Adapting Rift to that stuff is not hard from what I'm seeing. The hard stuff is how much information will we slosh around, how will we summarize to actually get computation good enough so it, it adds value, load balancing, but also fast enough that it's reactive to the timescales, to the flows that they're talking about. And from there on, for me, it's all about congestion control. I have absolutely no interest in because people build different things and they're in microseconds. I'm a slow guy.
Totally agree that for the routing protocol, yeah, it's about where we distribute, how we install forwarding state, what we summarize. And yeah, it's a little bit more interesting in Dragonfly, certainly doable. As for CLAW and Dragonfly, Dragonfly actually allows to build larger network from the same amount of links, but with same caveats, because it depends on traffic patterns. For random permutations, it's the same capacity as CLAW, but for adversarial patterns, it's like 1/2 of the CLAW. So that depends on traffic patterns. As for AI versus HPC, it's a big discussion, and it's my opinion, it's a little bit strange discussion because HPC is a very specific area, but all the machine learning training, it actually uses a subset of mathematics which is used in HPC, but it has really huge vectors. That means fat flows, large transfers, where HPC sometimes uses very small transfers, and a lot of different things from that. But that's probably a subject for, I don't know, TDD, next native, something like that.
Yeah, so we are not going to do any rechartering before main spec goes through ISG. We all agreed on this. So there's work that had been previously discussed on generalization of distribution of data, so service 6 as an example. And again, thanks to the fact that machine learning clusters are regular topologies, they're direction aware. So again, I think kind of not as a working group chair, as person involved in industry, that it's extremely suitable protocol to be used in this kind of topologies. So we'll continue next IETF the discussion. And again, everyone welcome to contribute and see where we get with it.
Okay. Thank you, everyone. Meeting's adjourned.
See you in Prague.